Thank you, and thank you also for allowing me to give 2 talks here today, because tomorrow it is Independence Day here in Finland. I will continue basically on what 2 other talks were speaking about, because there were questions from the audience that what are the benefits of creating domain-specific languages with MPS, and also what were the productivity side of low code. However, before I move to that subject, I would like to also comment shortly what Josh was mentioning, that there's a need to have tools on the web. I don't know how much you are aware of technologies today, but today you can pretty much run any application inside a browser, including, for example, modeling tools like this. So there's not necessarily no need to develop additional technologies again, because you can run things in the browser anyway without having people to do the installation. I'm just not sure whether you are aware of these cloud technologies being applied, but we have seen that they are quite heavily applied in practice to move things to the web, especially with these COVID times for some years now. So I'll address the talk from the topic that how companies measure the productivity. Basically, should they create a domain-specific language, and if they do, how they measure that it makes sense. And I'll do it by showing 3 practical cases of different kind. And basically, the main challenge that companies have is that, okay, if I create the language, is the biggest value, for example, improved validation, like it was the case by Tom, or is the value productivity, like in the case of low code by Stefan? So when we have asked and looked why companies are creating domain-specific languages and how they measure it, of course they can look not so good ways to do it, like lines of code, but nobody sees any more code if it's modeled. Maybe it's something more abstract, like function points, or maybe quite often developers are keen on looking how many clicks or other efforts they need to do in the tooling, or maybe it's just about people's opinions. Is it user-friendly? There are, of course, studies made in academia, like, can I, using 2 different kind of languages, which one is able to complete the given tasks, or if I can complete the tasks, maybe I have still errors or bugs in my deliverables. So is the language more on helping the quality side? But what we have seen most typical in practice over the years is that most companies are keen on the productivity side, the development time. And one reason is that it works very well over different languages, and time acts very well as a proxy for the costs. And many companies use money for many other purposes, also budgeting, salaries, project planning, and things like that. So, however, and I have a background in academics, so what I have found out that even though there's a great research done in academia, companies very rarely make proper evaluations, simply because they consider that they have a high costs on making those. And quite often the many good scientific research methods are way too complex, and they may not necessarily even know how to do them properly. So what I'm showing here next is something that if you are an academic person, you don't like, but I'm showing what happens in practice. So I'll show a few studies on how companies are doing things in practice and what has been the results. This first one is a little bit like what Stefan was saying about low code. there's a company who has created their own low-code development environment. And this gives them the extra productivity improvement that if they are not locked into any particular low-code environment, because they can change the language and generators for their own needs. So here you can see a couple of screenshots of the type of applications they are building. And what they wanted to do is that they wanted to do a comparison. So they built the application two different ways. The obvious first way with web apps is that you apply SQL for schema, you implement the business logic with some programming language in C#, and then you have user interface in JavaScript and HTML. And then they did another approach by building their own domain-specific language, so you could say their own low-code environment where they model the application and then they generate almost everything from these models. The only thing why it's not no-code, but it is low-code, because after they generate it, they add the user interface in SQL, the definition. So what they did is they implement these two different ways and compared the effort by using a small example. You will see here very typical enterprise, very typical entity relationship type model for the application for the project management. This is the only piece of model we are allowed to show. The language also has other parts. In my opinion, they don't necessarily have any specific aspects, but since we must follow the NDAs, we cannot show the other aspects like user rights and roles and things like that. But basically, they build this kind of application with customers, they passwords, resources, and technical information, and then generated the code. And then they measure the time. And based on this, they basically find that the traditional way of defining the schema, programming the C# business logic and user interface causes something like 36 hours of work. And when they applied the modeling language and they have built by themselves, the development time was fundamentally faster. So it was very clear then to continue using this approach they have built. Interestingly, the setup for the internal tool was not so easy than when they were using existing off-the-shelf tools. If you would be an academic person like me, you would not like this kind of result because there was only one person who implemented this, only one application, and we could consider that, well, what if there would be more developers? What if we would need to maintain this application and things like that? So luckily, some companies have done more extensive evaluations, and this is the one company which makes sports instruments by using languages, something like this for the user interface. So basically half of the code of these devices are something that the consumer sees, and half of the code is something that is always the same, like battery management, reading your heart ratio and things like that. And they did the same kind of thing. One person built the system again and measured the time. But then he was able to ask from the management that, can I have 6 other developers to do limited experiments? Some were new developers and then others have been doing it a long time, and then they measured the time again. And they found out that, okay, it was faster to use that. But because this is a company in Europe, individual developers have a lot of opinions that they would like to express. So they did a clever thing that they also asked from the people that what you consider this approach, just based on your own opinion, using the domain-specific modeling language they created or using the old way C programming basically with their devices. And just asking the opinions. And they were basically, for example, very happy that when they built the code generator, the programmers thought that the code they are generating is better than they are writing manually. That they were very happy to see. But what this language that I showed you, it was given for programmers. And when these devices are built, we have also other kind of phases where we have in the development of these products. There are people who do concept design, usability, implementation, localization, tests. So one aspect of really evaluating the language would be that what if programmers don't use this language, but actually we give these kind of languages to the user interface people, because there is no programming here involved. Rather than asking that, okay, modeling replace programmers' work. So it would be better to look, what if the evaluation would change the bigger life cycle or involve other kind of roles in the development than just traditional developers or programmers. And this leads then to the third example, that is my favorite example, because the company has put this in Austria, has put this into extreme. So it's a company which makes systems. They make fish farm automation systems. And they have a different kind of functionality in these systems: hardware, database schema definition, user interface definition, communication networks, material needs, and then a third-party company goes and installs these systems. So what they did is that they built a domain-specific language looking like this. And what you can see here is basically these blue ponds. And these ellipses are the ponds where the fishes are. And then there are other concepts like aerators, different kind of sensor for pH value, temperature, muddiness, and so forth. And the domain-specific language then guides them that the sales engineer can go and just add the ponds there where they are in the real world. And then maybe someone else who knows that there is a need for aerator, that a third person can then know that, for example, given that there's an aerator, how the oxygen is provided for this type of aerator. And then there can be electrical engineer who uses the same model to do the electrical engineering work. And at the end of the day, once the system is done, they can then run from the single model various kind of outputs. Not only the database code or the logic code or the user interface code, but also the installation guidelines, bill of materials. And in fact, they go so far that they even generate the stickers for the firing closet. So when someone rows in the boat and puts the cable to the cabinet, they can put the sticker there that is also generated from here, which is very different from the practice that different people are maintaining different kind of required artifacts individually and trying to keep these inconsistent. So what they did also comparison. They did the comparison by comparing to this clone and own approach. So they don't write the code completely, but they take previous close delivery of a fish farm and then change the code and then compare it to modeling to find out that there's a 800% difference on the software side. But interestingly, because large portion of the work goes to the installation of these kind of large systems, errors have also a big role here, because they found out that in manually written clone and own documents, they had these errors, so they needed to repeat these and do extra work for this approach compared to the modeling. This is just the one case, but they repeated this 4 or 5 times. And they basically found out that, okay, the productivity will increase. But we could still again ask that, yeah, well, what if we maintain the systems? Because we know that the systems need to be maintained, and that's normally the bigger portion of the software. And how about repeating this over time? So not just one system, but let's collect the data from 2 years. And things like that. So what we have found out is that good enough evaluation method is often accepted in companies. and effort in time can be collected still relatively easily because time is very well understood. And maybe in our case, for example, the tool can collect the time and make logs. But at the end, the evaluation should be adapted to different situations, like who are the language users and what portion of the life cycle need to be covered. I understood from the two talks earlier today is that there were only one type of user who is using the language, but quite often there are also others who read the documents, or like with the fish farm, there are other people who use the product artifacts to do deployments. So the languages can have bigger impact for those kind of people as well. And then very rarely we have seen that companies evaluate different languages. So this is an example in a warehouse domain where a company implemented two different kind of languages. This one, which is more like how to say, nested dialogues. You click an element and it opens more detailed dialogues, or you have more visual language and you have two languages, basically two sub-languages that are more visually. And they basically found out that in their study that having two languages is faster than having just one language. But very rarely companies do this kind of evaluation, partly because maybe it's too costly to build these two alternative languages. But one thing that also I would like that, especially because there are academic people here, is that very few companies and academic papers reported say about how big has been the effort to create these languages. So I would be very interested to hear about, for example, the effort to create the MPS languages given in the financial domain. But these are the studies that we have tried to collect, and there are also publications made by us. So if you are interested to look how long it takes to create these languages, we can share some of the data. For example, these Polar Sport watches was 8 working days, including C code generator. So to summarize, what we have found out from practice is that development time is most commonly used measure to say that, well, does creation of the DSL make sense? And we also seen that companies can do evaluations if they are very modest investment. But if the investment is bigger, or we require two groups, like doing a proper academic research, companies don't want to do that. And therefore, that is also my question, or my hope for you, is that if you are interested in empirical research, could you provide some principles for companies to decide should they apply modeling or not, and how to find out the answer, maybe in different level of investment that they need to do to find out the applicability of their language. So this is my side of the talk. I would be more than happy to hear your comments or questions, and also obviously your experiences.
Thank you very much.